Okay, this is the review for lesson 2.7. This is a transformation of linear functions. So we're going to start off with what we call the parent function, which is our basic function. So for linear graphs, our basic function is one that passes through 0, passes through the origin, and has a slope of 1. And we can see this nice, perfect diagonal line here. And the equation for this is y equals x, because as there's no number at the end here, that means that it passes through 0. X is 1x, and the amount of x tells us what the slope is. And you can see that it indeed goes up 1 and then goes right 1, which is what a slope of 1 is. Now, the child function is basically something that's very similar to the original function, but it's just a little bit different. So some lines are very close. Like this line here, we can see has the same slope as this line here. This line here has a positive slope, but it's not exactly the same as this one, and also has different intercepts. And then sometimes we have some very different lines, but you can still see that it's a straight line. So in transformations, what we're looking to see is how do we change from one function into another function? And that's what we're going to look at in this lesson. Now we're going to look at it by looking at the properties of certain functions. So we've already done this in an earlier lesson. So as it just says x here, I know this is 1x. And in fact, for all of these, this is 1, because it says x. Our intercept is the number without the x, as long as it starts with y equals. So this would be positive 1, positive 4, negative 1. It's important we look at the sign here. Don't just take the 1. We have to take the negative that goes with it as well. And similar reasons, then negative 3 on the end there. Now, if we actually type these in, let's actually look what happens. Now, the important thing was, from the table, what we should have noticed was that all the lines had the same slope. So as we're looking at these functions, what do we know? What is the same about each line? Well, it is the slope. And actually the word we can use then to describe these lines are, if they have the same slope, they're parallel slopes. And we'll be looking at that in module 3. Now, the thing that's different for all these then is the y-intercept. So the one that's negative 3, notice it passes through negative 3 on the y-axis. The one that says x plus 4, notice that it passes through positive 4 on the y-axis. And if it's just plain old y equals x, then it just goes through 0, of course. So what effect does change in B have on the parent function? Basically, it decides where the graph actually starts from. And what it also does is it decides actually how much we move the graph up or move the graph down on that starting point. So just in case we didn't have those graphs, I have them here. So what you can see is that x plus 4, you can see that it starts at 4 places higher on the graph. Whereas x minus 1, you can see starts 1 lower on the graph. So our first transformation actually is these things at the end. The numbers at the end here actually tell us how many squares we move up or how many squares we move down. And we used to describe that word as we use translation. And you can actually see here, it kind of looks like it's moving left and right. But if you just focus on the y-intercept, notice that the y-intercept is moving up and then it's moving down. And that would be our first one. So to look at the functions here, the green line shown in the graph has been translated at 5 units. What is the translation of the blue line? Well, you can see that it's been moved down 2 places. So I'm going to put down 2 places. And if I had to describe that line, it would be y equals x minus 2. So it shall go down, I give it a negative sign. And notice also that it clearly on the graph here goes through negative 2 as well, which is why we have that negative 2 there as well. And for our second little investigation we're going to look at here is, this time notice the slopes are not the same. So I've got 2x here, so that's a slope of 2. 1/2 x, that's a slope of half. Negative 5x is a slope of negative 5. And negative 2/3 x has a slope of negative 2/3. As it starts with y equals, and there's no other number at the end, that must mean that the y-intercept is 0 for these ones. And as I type these in, there's 2x, which you can see is steeper than 1x, not surprisingly, because 2 is bigger than 1. 1/2 is smaller than 1, and notice that the slope is lower as well. Negative 5x, you can see actually is a totally different direction, but you can see it's kind of a lot steeper than the one that was 2x. If we look at the slope for 5x, negative 5x, you can see that it's much steeper because obviously 5 is bigger than 2, but in a negative direction. And then negative 2/3 x, as negative 2/3 is less than 1, I would expect this to be a little bit less than y equals, but also in a negative direction as well. So what effect does m have on the parent function? It changes the slope. If it's negative, it will be going downwards as we read left to right. And if it's positive, it will be going upwards. And that's all the graphs in one place, just so we can see them easier. Now, I added a slider on here as well. I put M as my slider, so this is the slope. So notice as the slope gets bigger, once it's 1, that's the original function. And then once I get bigger than 1, you can see that it gets steeper and steeper. As I get less than 1, but still positive, you can see that the slope is less. Once I get to 0, obviously I get a horizontal line. And then as I get negative, you can see the same sort of thing. The more negative the line gets, the steeper it gets. And if it's at -1, you can kind of see it's the same slope as this, but in the opposite direction. And as I get between -1 and 0, you can see that it's less steep than the line y equals x. Now, what's actually happening on here is, and it might look like, from as I was using this, it might look like it's twisting or rotating. What's actually happening is we're actually stretching this graph out. Now, if I was to take this point, let me set this to y equals 2x. This might be easier to see then. So for my point here at 2, notice that the graph above is a height of 4. So in other words, it's actually doubled. Perhaps if I zoom out, we might be able to show this for other points as well. So where the slope here is 5, notice the graph on this one is 10, because I've done a vertical stretch, scale factor 2. Now, if I was to set this to say 1/2, which would be 0.5, you can see that actually it's half the height of what the original graph is. So this was 5, this is 2.5. And so actually it's almost like a squash in some ways. So that's what actually is going on with our our transformations for this one. Vertical stretches and vertical shrinks when we put our number in front of the x. So for a line y equals 2x, that would be a vertical stretch, scale factor 2. And for the quarter x, that would be squashed, and it'd be a quarter of the original value. And then we come to our little activity. So I'm going to just run the first one just so you can see what happens on our marble slide. If we click launch, the marbles drop because of gravity. And then through the line here, you can see that it didn't quite get through the stars. The aim is to get through the stars. So actually, I want this line to be lower than what it currently is. So I know the part that moves up and down then is this part on the end here. So I want to move this down 1, 2, 3 squares. So if I'm currently at 1, if I subtract 3 from that, I know that's -2. Now, we might not always be able to do these straight away. So it might be a case of you might have to guess a little bit for these. So I'm going to put -5 first of all. And you can see that that's way too low. So that's certainly not going to work for this one. Oops, actually, I meant to change this one up here. Let me change that one. But I know -5 is too low. So I'm going to go -3. And that's still a little bit too low. So -2, that looks about right. And notice 1 take away 3 is indeed -2. I'm going to get rid of that line because I don't really need it. And now when I launch it, I can get through all the stars. And there's similar ones for you to try as well on 2, 3, and 4. On these first few, you should only change one thing. So first of all, like if I'm doing this question here, I should check, like, is the slope the same? It certainly looks like the slope's the same. So I will want to change just where the y-intercept is for this one. And if I'm looking on one like this, I can see that the slope is not the same as this slope here. So I would want to change this value here for the slope. Notice also we can use the facts we've used from our previous lessons. Is I can work out the slope of this by using rise over run. So I could figure out how many squares do I need to go down, how many squares do I need to go across to indeed figure out what the slope is for this question. And then after you've had a practice on those, there are a few that have no clues at all. You've got to type out the whole equation. Got 1 star, but you've got to get all the stars. And another one here. And another one here. Now, just a reminder from our unit on functions, when we put f of x, that's the same thing as y. So for our last units, as we've been graphing, we've been putting y equals for everything. But just remember that's the same thing as f of x. So if I have a couple of functions like this, I can see that the slope of this graph is 1, and I can see the slope of this one is 1/5. It looks like I'm actually answering the second question first here. So the graph of this compared to this, I know it's going to be less steep because I know 1/5 is smaller than 1. When I look at the intercepts on here, this one is 0 and this one is 2. So to get from 0 to 2, I notice I must go up. Now it's important you make sure you get this the right way around, because if I go from 2 to 0, clearly I would go down 2. So to get to G from F, that means I start at F and go to G. And I don't think there's a check button on this one, but that one is certainly right. I think the little graphing thing there is, of course, if you want to graph the line so you can see what they physically look like, that can be something you use as well. So this one goes from 0 to -7. So that would be going down as I'm comparing y-intercepts. And the slope, this is 1, this is 4. As obviously as 4 is bigger than 1, that means that this would be steeper. Now, the questions can get more confusing when they give you one graph, this is g of x, and then they give you one equation. Now, you could certainly type in both equations if you wanted to, or if it helps, you could also think about drawing the graph to see what this looks like. So I know x, I know it starts at 0. I know a slope of 1 means I go up 1 and across 1, up 1 and across 1. And I could join this up if I needed to as well. There we go. Now, also, this requires our vocabulary skills as well. So the slope for this one is 1. The slope for this one, I've kind of got to count it out a little bit. I can see that it goes up 2 squares and across 1 square. So I know the slope of this line is 2, and I know the slope of this line is 1. So twice means times by 2. So 1 times 2 is indeed 2. Clearly not 1/2, because that would be a lower slope. 2 less than means you're subtracting 2. Obviously, 1 take away 2 is not 2. And 2 more than means I'm adding 2. And 1 add 2 is not 3 as well. So I know some people really struggle on the vocabulary. And when we covered these ones in class, they could see what the numbers were, but they had to think a little bit more about the vocabulary. For the y-intercept, well, for this one, it's 0. And for this one, it's 2. So this would actually be 2 more. 0 plus 2 is 2. And then I have my answer. I want to pause the video just for a second, try question 4, and then we'll come back and show you the answer. So once again, it's got y equals x. And again, so we know that this it goes through 0, and also that it has a slope of 1. And then we can start to answer some of these questions. So for the slope, for the f of x, it is 1. And for g of x, it looks like it goes up 1 and across 2. So this one is, you can see that this is less. And you can see that it's 1/2 as well. There's my answer, it's 1/2. If you do a half of 1, you get 1/2. And for the y-intercept, it's 0 on this one. And then on this one, it's -2. So clearly this is 2 less because I went down 2. And that would be it for this one. This one we've got to actually graph something. So let's read what it says. The graph of g of x is shifted down 1 unit. So when I'm shifting down, I'm looking from the y-intercept. So I'm going to go down 1 square. And it's 3 times as steep as this. So this is a slope of 1. So 3 times as steep, 1 times 3 is 3. So I need a slope of 3, which means I go up 3 squares and then right 1 square. Up 3 squares and right 1 square. Normally, of course, once you've plotted 2 points, it will join it up. I just had to go to a little bit more trouble there. And for the last one, shifted up 3 units. So 1, 2, 3. So I'm looking at the y-intercept, in other words. And 1/2 is steep. So this has a slope of 1. So I need a slope of 1/2. So that means I go up 1 and then right 2. Rise over run again. And then as I join this up, you can see that it has a slope of 1/2 compared to a slope of 1. And I'm done for this one. That concludes the video for this one. There is an assignment that goes with this. So go check that out and go practice those skills a little bit more.